Welcome to your screencast for Module 9, Lesson 2. Remember, we are dealing with systems of linear equations, which means basically more than one line on a particular graph with the same variables. Usually our variables, remember, are x and y, but we might use different variables depending on the situation. Anyway, so this first example that we're going to deal with illustrates sort of the second method that we're going to use for solving linear systems. Remember that lesson 1, we solved linear systems by graphing both lines, seeing where those lines intersected, that thing. Okay? We have another method to solve linear systems, and that is solving linear systems by substitution. Okay? So we're going to just get right into it and do some examples together so that you guys understand what you're doing. So here's your linear system, and I'm sorry I've already doodled on it, but anyway, we have two lines. First of all, you have a line that says y equals 2. Remember, that could be y equals 0x plus 2, meaning the slope is 0. This is a horizontal line. So that's your first line. Here's your next line, x plus y equals 6. Now, x plus y equals 6 just so happens to be written in standard form, but that's not a huge deal. Okay, and what we're going to do in this method is basically we're going to stick one equation into the other equation so that we can eliminate a variable. Okay, so this one's a really simple example because I don't have to do a whole lot of work. It already tells me up here y is equal to 2. So down here in this second equation, what I'm going to do is say x plus what y is equal to, which is 2, equals 6. Okay? So I have substituted this equation into the second equation. And when I do that, I no longer have two variables. I no longer have x and y because I put in what y was equivalent to, which is 2. Okay? And then that makes it really easy to solve for x. So when y is 2, x is 4. So the values of x and y are known. What's the solution of the system? Well, 4, 2. That is the ordered pair. That's the solution. So if you were to go back and do the first method and graph these two lines, this one would be a horizontal line, this would be another line, but they would cross, they would intersect at this point. All right, let's go down to the example at the bottom. All right, I'm now at example D. It says use substitution to find the values of x and y in this system of linear equations. Substitute 4x for y into the second equation and solve for x. Okay, so here, where am I? Y is equal to 4x. That's your first line. And then you have a second line, 5x plus 2y equals 39. Again, it's not in slope-intercept form, but that's no big deal. Okay? You know from this equation what y is equivalent to. Y is equivalent to 4x. So I can put 4x or I can put y. Those two things are equal. So over here, I'm going to put what y is equivalent to instead of writing y. Okay, so I'm going to put 4x in here. Okay, so we're going to get 5x plus 2 times what y is equivalent to. So that means 2 times 4x equals 39. Okay, so that's kind of what I'm doing down here. 5x plus 2 times 4x, because remember that's what y was equivalent to, equals 39. Do the distributive property and you get 5x plus 8x equals 39. 5 and 8 together, that's 13x. So 13x equals 39. Divide both sides by 13 and you're going to get that x equals 3. And once you know what x is, then you can go back and put x in right here. 4 times 3 and y is equal to 12. Okay, so basically you're taking one equation, substituting it into the other equation, which allows you to have an equation that only has one variable now, okay? Here it had an x and a y. If we put in what y is equivalent to, 4x, now we have an equation with only one variable, x, and we can solve for x, okay? And then once we know x, we can go backwards and figure out our y. And again, you could do this with the graphing method that you learned yesterday. You would simply graph this line. You'd probably need to take this line and get it in slope-intercept form, but then you would graph that line, and the point where they cross is your solution.